Good morning. Today we are going to discuss wave propagation. What is meant by wave propagation? What are the different types of wave propagation? So let us see here. This is our Earth surface. Let us consider this is our Earth surface. So this is our transmitting antenna, and this is our receiving antenna. Let us consider this is my transmitting antenna, and this is my receiving antenna. So from this transmitting antenna, we are transmitting 1 kilohertz signal for one application. Similarly, 1 megahertz signal for one application. Similarly, 1 gigahertz signal for some application. Means you are transmitting different signals for different applications. Okay, so whatever the signal transmitted by the transmitter, that will be received by receiving. So my first question is, will all the signals, either 1 kilo signal or 1 megahertz signal or 1 gigahertz signal, will travel same height from the earth surface? Definitely my answer is no. One signal may go deeper into the atmosphere. One signal may go like this. One signal may go like this. Based on this, how the signals are transmitting from, what are the different frequency signals, means based on the frequencies, means here in the antenna terminology, frequency means application. For example, fm signal, fm radio, the frequency is from 88 megahertz to 108 megahertz, 88 megahertz to 108 megahertz. So here the application means, if I want to transmit 88 megahertz to 108 megahertz, what is the mode of propagation? So here there are three modes of propagations. There are three modes of propagations. The first one is ground wave propagation. First one is ground wave propagation. Second one is sky wave propagation. Sky wave propagation. And the third one is space wave propagation. Space wave propagation. The other name of the space wave propagation is we also call it as tropospheric wave propagation. The other name of sky wave we call it as ionospheric wave propagation. The other name of ground wave is we can call it as surface wave propagation. So by using the ground wave propagation, I can transmit the signals whose frequency is less than 2 megahertz. Less than 2 megahertz means all the signals or all the applications whose frequency is less than 2 megahertz signal, I can propagate my signal from my antenna. This is my earth surface. I can transmit from transmitting antenna to receiving antenna through ground wave propagation. Whose frequency is less than 2 megahertz. Similarly, coming to the sky wave propagation, the frequency is the 2 megahertz to 30 megahertz. 2 megahertz to 30 megahertz. So by using this sky wave or ionospheric wave propagation, those frequencies in between 2 megahertz to 30 megahertz, I can transmit using sky wave or ionosphere wave propagation. Those frequency signals greater than 30 megahertz, I can transmit using space wave or tropospheric wave propagation. So once again I repeat, those frequency signals less than 2 megahertz, I will go for ground wave propagation. Those frequency signals in between 2 megahertz to 30 megahertz, I can propagate using sky wave or ionospheric wave propagation. Those frequency signals greater than troposphere or greater than 30 megahertz, I can transmit using space wave or tropospheric wave propagation. So totally there are three modes for transmitting any signal from transmitter to receiver. Let us see the basic block diagram where we can transmit all the signals. Let us consider this is my earth surface. This is earth surface. Consider this is the transmitting antenna, and this is receiving antenna. This is receiving antenna. So coming to this transmitting antenna and receiving antenna, so first ground wave propagation. Ground wave propagation means, I initially told that ground wave propagation whose frequency is less than 2 megahertz. All the signals I can transmit like this. This is the ground wave propagation. I am representing this is with A. A indicates ground wave propagation. A indicates ground wave propagation. Ground wave propagation. So means whose frequency signals less than 2 megahertz signals I can transmit using ground wave propagation. Okay, so this is transmitting antenna and this is receiving antenna. Okay, next coming to the skywave or troposphere. So we know that different layers of earth surface. Here we are having troposphere, on that we are having stratosphere, on that we are having ionosphere. So ionosphere, it extends in the atmosphere from the above the earth surface. Ionosphere extends from 50 kilometers to 400 kilometers. 50 kilometers to 400 kilometers. So any signal, any frequency signal in between 2 megahertz to 30 megahertz, that signal will go by ionosphere or skywave propagation. Means it enters into the ionosphere. It enters into the ionosphere. So with green color, it enters into the ionosphere. It enters into the ionosphere and bend backs and come to the receiver. So I am representing this with B. I am representing this with B. B indicates sky wave or ionospheric wave propagation. Sky wave or ionospheric wave propagation. Next, third one. Any frequency signal greater than 30 megahertz. Any frequency signal greater than 30 megahertz I can propagate using the third mode, that is troposphere or space wave propagation. Troposphere or space wave propagation. Right now I am going to the third mode of propagation with the yellow color. So here this is transmitting antenna, this is receiving antenna. So one is direct, I can call it as, this is direct one, directed or LOS propagation, line of sight propagation. There is another way of transmitting the signal. It comes to the earth surface and touches the earth surface and reflect back and goes to the receiver. So this is the third mode of propagation. This is the third mode of propagation. This is C1 and this is C2. So C1 is direct path, C2 is indirect path. This is how different signals travel from the earth, from the transmitter to receiver using this three modes. Okay, third mode is space wave or troposphere wave propagation. So these are the three modes.